NASA's Voyager 1 spacecraft, which currently holds the record for the most distant object ever built by humans, has fascinated individuals globally for nearly 5 decades. Since its launch, Voyager 1 has sent important data from the farthest reaches of outer space, improving human comprehension of the universe. However, the probe's recent broadcasts have demonstrated anomalies that are unusual and have left specialists perplexed. These enigmatic signals have ignited intense discussions, causing the research community to question whether these irregularities are mere technical malfunctions or signs of a far more extraordinary phenomenon, potentially even extraterrestrial involvement. Join us as we explore these perplexing messages and investigate what might be hidden in the vast expanse of the universe. The fundamental human desire to uncover mysteries has long driven our endeavor to explore space. This profound curiosity paved the way for ambitious projects such as Pioneer 10 and Pioneer 11, which were among the most daring space missions of their era. On August 20th, 1977, the Voyager 2 launch from NASA's Kennedy Space Center commemorated the beginning of a groundbreaking era in space research. Shortly thereafter, on September 5, 1977, Voyager 1 was dispatched into space, embarking on a journey that would lead it to the outer planets, dramatically altering its trajectory and scientific findings. The probe, with an approximate mass of 721 kilograms, comparable to a compact automobile, traveled in a distinct direction on December 15, 1977, at varying speeds. An important milestone was reached. Voyager 1 outperformed its twin in terms of distance covered due to their divergent paths. Since then, Voyager 1 has served as a crucial asset in deepening our perception of space, offering discoveries that have transformed our understanding of the universe. Before delving into some of its recent groundbreaking findings, let's revisit several of its earlier key accomplishments. Positioned roughly 265 million km from Earth in 1979, Voyager 1 captured high-resolution images of Jupiter. By January of that year, it had completed an impressive 100-hour study, resulting in a time-lapse sequence that depicted the rotation of Jupiter. This set of 3,750 images offered unparalleled insights into the planet's turbulent atmosphere and complex features. During this mission, Voyager 1 also uncovered a previously unknown ring around Jupiter and 2 undiscovered moons, significantly enhancing our knowledge of the gas giant's intricate system. To maintain its course and avoid colliding with Titan, one of Saturn's moons, the probe performed several navigational adjustments. Subsequently, the mission shifted its focus beyond the solar system's planets as the spacecraft was redirected into interstellar space, traveling at a remarkable rate of 325 million km per year. In January 1990, Voyager 1 commenced its assignment to explore interstellar space, pressing onward beyond the confines of our solar system. During this phase, it accomplished several exceptional feats, such as identifying for new moons Mimas, Enceladus, Tethys, and capturing some of the best-known images from the solar system's outer boundaries. On February 14, 1990, located approximately 6 billion kilometers from the Sun, Voyager 1 took the iconic family portrait, a panoramic collection of images of the inner planets. This compilation of 60 pictures was added to the probe's extensive gallery, which already included hundreds of images from its close encounters with the gas giants. Voyager 2 simultaneously captured remarkable points of interest along its journey. On Neptune, it measured wind speeds exceeding 2,100 kilometers per hour, roughly 1,300 meters per second, the fastest atmospheric currents ever recorded in the solar system. It also observed Triton, the largest moon of Neptune, where temperatures plummeted to a frigid 391 degrees Fahrenheit, 235 degrees Celsius, ranking it among the coldest known locations. Triton exhibited signs of icy eruptions, spewing nitrogen gas and revealing frozen debris up to 5 kilometers highlighting new and fascinating aspects of its geology. These extraordinary discoveries significantly broadened our comprehension of the numerous and dynamic conditions outside the solar system. The missions of both Voyager 1 and Voyager 2 have been truly transformative. Their findings unveiled Jupiter's hidden characteristics and Saturn's moons. Once thought to be inactive, redefining beliefs about their geological activity. In particular, Voyager 2 made history as the only spacecraft to date to pass close to both Uranus and Neptune. An unprecedented success. NASA employed a series of innovative strategies to prolong these missions' lifespans, such as powering down non-essential components to conserve energy. The endeavor is expected to last until 2030, marking the conclusion of a remarkable chapter. For the teams who dedicated themselves to this mission, the construction of Voyager 1 and Voyager 2 exemplified advanced design. Designed for slow rotation, the probes minimized motion blur in their images during travel. Even before reaching the outer planets, the spacecraft began relaying detailed visuals of Jupiter, unveiling its swirling clouds and the well-known Great Red Spot, a massive storm that has intrigued scientists for decades. One of the most thrilling discoveries was the detection of active volcanoes on Io, one of Jupiter's moons. The instruments aboard the spacecraft encountered odd readings from the moon, later validated by images revealing massive volcanic plumes and a violently reshaped surface. One eruption on Io was found to be 1,000 times as powerful as Mount St. Helens, covering an area close to the size of France. As their voyages continued, both spacecraft were gradually powered down to save fuel. Strikingly, though they did not capture images of Mercury or Mars due to technical constraints, NASA later launched additional noteworthy missions, including New Horizons Pioneer 10, Pioneer 11. On February 17, 1998, Pioneer 10 surpassed Pioneer 11 and became the most distant probe from Earth. However, Voyager 1 carried on with its journey for another 14 years, before officially penetrating interstellar space on August 25, 2012. A pivotal factor in the triumph of these missions was the strategic utilization of gravitational slingshot maneuvers, which propelled the spacecraft toward their objectives while conserving fuel. Rather than entirely relying on propulsion systems, they made use of planetary gravity to accelerate and change course. This technique enabled them to span colossal distances with minimal fuel expenditure. As Voyager 1 approached Jupiter, the planet's immense gravity accelerated the spacecraft. Precision was essential for avoiding dangerous shifts in speed or trajectory. These gravitational boosts enabled the probes to perform expertly. Voyager 2 likewise exploited gravitational pulls from Saturn and Jupiter to move toward Uranus and Neptune, validating the efficiency of this navigation method. Reflecting on these extraordinary undertakings, the scientific community eagerly awaits additional information from the anomalous transmissions recently detected by Voyager 1. The spacecraft continues functioning far beyond the solar system's known perimeter, probing the mysteries of planets like Jupiter, Saturn, Uranus, and Neptune. Voyager 1's time-lapse sequences vividly documented 10 eruptions on Jupiter and revealed new satellites, in addition to a previously unrecognized rink, continuing to redefine humanity's understanding of the cosmos. All around the world, these revelations have substantially enhanced our understanding of the Jovian system. Similarly, Voyager 1 discovered for moons Mimas and additional Saturnian moons Enceladus, Tethys, and in addition to providing breathtaking visuals of the planet and its rings, which shed light on their elaborate structures. The mission's expeditions to Uranus and Neptune made important observations about their satellites and atmospheres, improving our understanding of the solar system's distant territories. After finishing their planetary flybys, both probes set course for interstellar space, where they persist in collecting crucial scientific data. This ongoing investigation widens our perspective on the far side of our rapise of our solar neighborhood, as we await new developments pertaining to Voyager 1's peculiar emissions and their repercussions for our comprehension of the cosmos. The incredible journeys of these probes continue to inspire both researchers and enthusiasts globally. Their achievements endure foundational in expanding human knowledge and pushing the boundaries of space exploration. Voyager's space exploration programs have provided previously unheard of glimpses of our solar system in regions far beyond, offering valuable imagery, iconic visuals, and significant scientific results. In addition to their spacecraft's empirical contributions, they carry a symbolic message crafted to represent Earth to potential civilizations from other planets. The Golden Record contains greetings in 55 languages and music from a variety of cultures and natural sounds such as thunder and whale songs. This interstellar communique serves as humanity's hopeful attempt to connect with intelligent life. Beyond Earth, Voyagers 1 and 2 were equipped with an array of scientific instruments that significantly enhanced our comprehension of space. These included magnetometers, plasma wave sensors, and imaging tools, all of which supplied critical data about space environments. The magnetometers helped unravel the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, explaining how these fields and plasma interact with their wave detectors provided insight into the impact of solar winds on the atmospheres of planets. One of the mission's standout achievements was tracing the boundary of the heliosphere, vast region populated by electromagnetic waves and solar particles that envelop the entire solar system. As Voyager 1 approached this boundary, it witnessed a shift from solar wind to essential interstellar material, providing insight into the protection this barrier offers Earth from cosmic rays. The SPACECRAFT pinpointed a location called the termination shock, where solar winds condense and slow down. Beyond that lies a turbulent area enclosed by the heliosheath, where solar and interstellar particles collide, creating a dynamic environment. Voyager 2's expedition also greatly improved our understanding of the outer solar system. It's close. Pass by the giant planets provided crucial information, particularly about magnetic fields, which were found to be inclined in unexpected ways that defied existing theories. These findings have stimulated further research into planetary attraction. These endeavors not only advanced scientific understanding, but also rekindled public interest. In space exploration, the mesmerizing images of distant planets and the captivating stories behind these missions have inspired countless individuals across generations. Iconic visuals like Saturn's elegant rings or Jupiter's volcanic moons have come to symbolize hope for new researchers and potential explorers. As the Voyager spacecraft continue transmitting exceptional information, their prolonged exploration of interstellar realms offers unmatched opportunities to decipher the fundamental nature of the universe. Although prior emphasis was often placed within our solar system's planets, delving into interstellar regions has revealed zones of surprising complexity. Once presumed void, these areas now demonstrate complex phenomena that challenge current scientific paradigms. One of the most intriguing findings is the detection of cosmic rays originating from beyond our solar system. Highly energized particles traveling nearly at the speed of light. These rays provide hints about processes occurring in remote parts of the galaxy. By studying their composition and energy levels, scientists aim to better comprehend the dynamics of distant stellar nurseries and broader galactic behavior. Moreover, as Voyagers 1 and 2 continue into interstellar territory, their onboard instruments keep evaluating the density and movement of the interstellar medium, the space between stars filled with gas and dust. This medium interacts with the solar wind and shapes the configuration of the heliosphere. During the probe's movement through it, they relay invaluable information that helps researchers model how energy and matter operate across cosmic distances. In addition to these contributions, the Voyager missions have revealed important Q information about magnetic fields in interstellar space, bringing their properties to light and highlighting their influence. These revelations could eventually lead to advancements in understanding magnetic forces throughout the galaxy. The ongoing exploration of these distant frontiers not only expands our comprehension of science, but also motivates future generations of space scientists and engineers. The unforgettable images obtained by Voyager, particularly the well-known pale blue dot showing Earth from over 6 billion kilometers away, serve as a humbling reminder of our tiny presence in the cosmos. These photographs, along with the missions, scientific accomplishments have deeply changed how we see our world and its position in the universe. The success of the Voyager missions has paved the way for even more ambitious ventures, thanks to the technological advancements developed during their expeditions. Launching advanced probes to even more distant reaches of the galaxy is becoming a realistic ambition. Objectives like exploring potentially habitable exoplanets and even interstellar travel are shifting from visionary concepts to practical goals for the future of cosmic discovery.